Alright, so today we are going to discuss about Taylor's method. And for Taylor's method, we use this formula in order to solve Taylor's method. So the question will be given to you as dy on dx equals a function of s and y, f of x and y. So in the question that you'll be having, it is in terms of s values and y values. So it's in terms of x and y. Now this is our initial condition. Y of x naught equals y naught. This is our initial condition. And this is the point that we are approximating to. So let's say s equals a. We'll be approximating it at this point. Now, for Taylor's method, we go by it with this formula. Y of s equals y x naught plus y prime of x naught multiplying x minus x naught on 1 plus y prime prime s naught x minus s naught squared 2 factorial plus y prime prime s naught x minus s naught all cube 3 factorial plus y power 4 prime s naught x minus s naught 4 power 4 over 4 factorial up to the last point. So this is the formula that we use in order to solve Taylor's method. Now we know y prime, but we don't know y prime prime. So we differentiate this one twice for us to get y prime prime. And also when you get the y prime prime, we differentiate again to get this one too. Very good. So let's take a question for instance. Now this is our question. Dy on the s equals s squared plus y squared. And this is our initial value, that is s naught equals 0, y naught equals 0 at s equals 0.4. So this can be written as y of x naught equals y naught. And we know that it's the same as y of 0 equals 0. Very good. It means that our s naught is 0 and our y naught is also, and our y is also 0. So y is the same as y naught and the x naught is the same as x. Now we are to solve using the Taylor's method. So how are we going to solve? Go by it. First of all, you need to write your formula down. And we know that for Taylor's method it is y of x equals y of x naught plus y prime Very good. So this is the formula that we are going to use in order to solve the question. Now we know y of s naught. Y of s naught is y of s naught, which is 0. So y of s naught is 0. We don't know y prime of 0. Y prime of s naught, we don't know. So unless we solve for y prime of s naught and also solve for y prime prime of s naught and solve for y prime 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 of s naught, so that you place in the values for the respective variables. So now let's solve it. Let's start solving it. Very good. So we are going to use this formula in order to solve this question. Now for our y prime, it is s squared plus y squared. We are looking for y prime of x naught, which is 0. Our s naught is 0. We know that x naught is equal to 0. So y prime of x naught, it means that wherever you see s, you place in 0. And wherever you see y2, we are going to place in 0 over there. y equals 0, that is y naught equals 0. So we're having x squared plus y squared, which is equal to 0 squared plus 0 squared, and our result is 0. So this is simply for y prime of 0. Now y prime prime of x naught is giving us we're having x squared plus y squared. So y prime prime, it means that we are to differentiate this again. When you differentiate this, we are getting 2x plus 2y y prime. This is the result that we are going to get. Now let's place in our values. We know that s naught is what? So y prime prime of 0. Our s naught is 0. So wherever we see s, we place in 0. Wherever we see y, we place in y. We know our value for y prime, that is 0. So it is 2 of 0 plus 2 0 multiplying 0. Now our result is 0. Very good. So we are having y prime prime as 0. Now let's solve with y prime prime prime. We are going to differentiate this once again. So to differentiate this, we are having to differentiate this, we are having 2 plus 2y prime prime. We are getting 2 plus 2y prime prime. Now we know the value for y prime prime, which is 0. So it's 2 multiplying 0, and the result is 2. Very good. Now we've gotten our y of x naught. We know that y of x naught is 0. Yes, it's y of x naught is 0. So we've gotten our y of x naught, which is giving us 0. And we've gotten our y prime of x naught. Y prime of x naught also gave us 0. Y prime prime of x naught also gave us 0. And y prime prime 2 gave us 2. So we just place in the value at wherever you see this respective differential derivatives. Okay. So we are looking for y of x. And now y of x is we are looking for y of x. Y of x is y naught. So our y of x naught is 0. So you write 0 over there. Plus y prime of x naught. Y prime of x naught is also 0. So write 0, and they are multiplying by, it is multiplying by s minus s naught. We know that s naught is what? 0. Just write 0 over 1. Any number is over 1. So you don't even need to write the over 1. It's not necessary. But just for you to understand very well. Plus y prime prime, and y prime prime we had 0. 0 multiplying by s minus 0 once again, all over 2 factorial, all squared, plus y prime prime prime, that is, we had 2. So we 2 multiplying by s minus 0, all on 3 factorial power 3. Very good. So we're having y of x equals 0, and this one too is given as 0. 0, this one too is given as 0, plus we're having 2, here is 0, here is 0, here too is 0, plus we're having 2s cubed all on 3 factorial. And we know that 3 factorial is the same as 6. So we are having 2s cubed on 6. So this is our y of x. And we are asked to approximate it at 0.4. We have to approximate x at 0.4. So it means that y of 0.4 is giving us 2 of 0.4 all cubed divided by 6. So you take your calculator and you punch for the answer. So we are having 2 multiplying 0.4 power 3 all on 6, and the result is 0.0213. So this will be our answer for the first question. Let's take another question.
Yes. So we need to